Hello everyone. Good evening. Good evening for the end of this first week of streaming the episode on PoC or GTFO. And this time, let me share my screen. It could help. Uh, yeah. So welcome everyone. And yeah. So we will speak about proof of concept or get the fuck out, PoC or GTFO. Hello, Grigory. And yeah, so in case you didn't know, this is a publication that I contribute to. And we did a lot of issues. I mean, we did 22. There is my mirror is at github.com/ange/PoC/GTFO. And this is my mirror and all the files. So it's issues with articles, and you can view them online. So you can view the articles online on archive.org if things work properly. I'm not sure, maybe they won't. Yes, so you see, you can view them online, and you can, but every file is also, except for the first issue that was a long time ago. I hadn't joined the project back then, I think. And the date, when is the date? The first issue was in 2013, so wow, some time ago. And I joined after issue 2 or 3, I don't remember. And we started making them polyglots, and we started them making like a bit of a crazy polyglots. And so after the very tiny examples of yesterday, where we just crafted by hand very tiny polyglots that, yeah, they worked, we could understand them, but this time these are like real polyglots that we had to combine to the make file, to the make system, and handle all the cases and so on. That was pretty that we used to be pretty difficult, especially initially. And also we had to test that in all kinds of software. We had all kinds of weird things happening. And but at least these PDFs are big. How big are they? The first issue. So the thing was, each issue contained the previous issue until some point, until we reach out the maximum size of a file to upload to GitHub or something. So basically, first issue was 200 K. Second issue was 3 megabytes, and 14 megabytes, 26, 56, 83, and at the same time they are polyglots, but they are, first of all, they are most of the time all zip and PDF, but something else. And even the technique that we use to make them zip PDF evolved with the time, with our mastery of the software. So any questions at this stage? No question at this stage. Okay, so let's look at first issue. And first issue was, we did load, was standard. Shamefully was, I mean, not shamefully, but you have to start somewhere, right? And was I part of the team back then? No, I wasn't. So that's really a long time ago. And no, so first issue was a standard PDF, shockingly. Like, my God, a standard PDF 1.5, nothing so too special. And at the end, there is a stream. And okay, one thing that you could notice is that even though there is a start xref, you cannot see immediately an xref, and you see images before. That's because in this case, I don't know if you see here, type xref. It's a new kind of PDF 1.5, how they're called, stream objects. So basically, the xref, the xref is itself compressed, because as you could see, the old school xref was full of redundant information. So they made it possible so that to have a compressed xref, in which case you have a specific object with the type xref. And here it's actually using compression. So you can see that it's using compression because it has the file decode filter. And you can see before that it's indeed an xref object, which is something that doesn't exist in previous versions of PDF. I mean, that cannot exist. So, and that makes this version much harder to abuse. And we will see later, I will do likely a stream on hacking stuff with the PDF LaTeX. And if you want a very easy to modify PDF, then you don't want this new 1.5 structure of a PDF with xref objects. Basically, you ask a PDF LaTeX to just generate a PDF 1.3 or something, and then it cannot generate such a PDF. And the others PDF are, as I showed, much easier to modify. Okay, so issue 0 was a standard PDF, but already we learned something. I mean, yeah, we covered a different kind of PDFs. Now, let's see issue 1. And issue 1, what do we see? So there is a flat decode, and yeah, okay, flat decode. We don't know what it is. Okay, it's compressed. Maybe it's a page. I don't know. I'm just curious. Okay, here we have what you can tell that it's a JPEG. You can tell where it's a JPEG in 2 easy ways. First, there is the filter DCT decode. That means DCT is the compression algorithm behind the JPEG. So this is the way for JPEG to say this is a JPEG compressed information. And if you notice, it's not just JPEG decompressed information. It's actually an entire JPEG. And the signature, you could tell that it's a JPEG because there is a JFIF signature, but it's actually not the actual JPEG signature. Some JPEGs don't have that. The actual JPEG signature is smaller, but it's always at offset 0, and it's FFD8. So basically, this just I never talked about JPEG before. I made a poster on that. Of course, it's on my GitHub. So as you can see, FFD8, that's the marker, the start of image marker, and then you have always a FF. Yeah, why not a small presentation of JPEG? Then you have FF and something that is not null. And so basically, application 0, app 0, the segment, it's called segment in the case of PDF of a JPEG. FF0 is the one that always contains the JFIF signature. And then there are different kind of segments, always starting with FF something. Very often there is the length just after the marker. But in the case of the big one, sometimes there is not the marker. Here you can see that the length is super short, and that's actually just the length of the parameters before the rest of the segment. And the segment is actually data terminated, I could say. It's not length terminated, which is making it pretty hard to parse. But if you want to just look for the next FF and not 0. If there would be an FF to be encoded in the file, in the data, then it should be followed by a 0, just to say this was a genuine literal FF and not a new segment that is started. And the end of image marker, the segment, is done with FFD9. So basically, very short introduction to the JPEG file format, but we don't need to delve into that. And there is, of course, a way to introduce comments. We will see probably in next issues with FF with the JPEG files. But again, it always starts with FFD8, and usually the first segment is one of the application. It could be application 0, application 1, and there are at least 14 of them officially. So FFE something, FFE 0, FFE 1, FF, and so on. But I think FFE14, FFE, what is it? ED is, I think it's Adobe Photoshop or something specific, whatever. But yeah, you get the idea. And the comment is FFFE. And then there's a length, and we will see that's how, this comment, a bit like a chunk, non-supported chunk in PNG. You get the idea. Okay. Hi, Sergio. Congrats for the effort. Which resource do you recommend to approximate learning the PDF format? My stream and the PDF specs, and then I don't know. It depends. The PDF. The question is, so to approximate learning the PDF format, just, you can play around yourself with the PDF and just a specification. The format itself is a bit always easy to manipulate because it always have the same naming and stuff. But then if you go the full length on the PDF format with all the standards and so on, it's an entire job. So it's not like I don't have a reference to an approximate reference to start that. But basically, the spec is not that bad, and it contains a lot of information. So and now PDF 2.0 specifications are free. So no, just a specification, playing with the command line tools, and nothing special. I don't know any others. Nice viewer for PDF. So nothing special for PDF, except playing around initially and then learning by yourself. But tooling, PyMu-PDF, which is a nice Python library that I use to manipulate PDFs, which is nice to handle the rest. Okay, so now let's go back to our file, second file. So now there's JPEG and another JPEG. So likely this is standard. And maybe at the end of the file, we have a surprise. And here we see something that we see a lot of PK, something, and nothing as smileys, which is very likely the end of a zip. So indeed, we have here the zip end of central directory. And before we have the zip central directories here, and you can see several of them before, So basically, that's a zip. And a zip, again, not very easy, not so easy. I mean, PK, so PK3, let's say PK1, 3, 4. So let's look for PK34. And that's the start of our zip. And indeed, we see that we were cheeky and we created a completely fake object number. Previous object number has also, again, we see that this is the object. This is the xref object because we see the type xref on it. We see the type xref here. And this is object 169, so most likely the one before is 168. And here we just inserted the dummy object with the object number 999, no length parameter because we were lazy back then, and then just a zip concatenated at the end of the file, so that again zip parsers can easily locate the end of central directory. And I guess we were a bit careless back then. Let's see the end of the central directory. So that's the end of central directory here. And we see that we didn't put a fake command, archive command, to hide the garbage. It would still work, but it would produce a garbage output. But yeah, that's just issue 1 down the memory lane. So, now we have something more interesting. So this looks like a PDF. But so we see the percent PDF, and to be honest, it's not really required, but why not? I mean, you could put whatever data you want before the PDF signature, but you see some garbage just before the after the PDF, the percent, and before the PDF signature. And what could that garbage be? And here we have some giveaways, and let's change view. And do we have this? No, am I wrong? Okay, I must be wrong. This is not what I expected. Let me check. Second look. No, okay. This is not what I expected. Okay. Anyway, the trick here is that the percent, it was used as an opcode, because why not? Because it's this issue was a bootable master boot record, so it's basically bootable, and 25 is basically can encode, and we are in 16-bit mode disassembly. I'm not going to explain disassembly right now, but you get the in short, these are CPU executions of x86 in 16 bits, and this the percent thankfully encode to a valid operation, and then we encoded the jump. So these first lines here are just fake and then a jump. So that's the start just before the PDF signature. So basically, that's a signature, a line comment in PDF, even though it was not strictly required that it's line comment before the signature. but then use, and then we have actual code, and definitely looks like it looks like x86 16-bit valid code, like interruption 13 and so on. I mean, I'm not sure if you're familiar with it, but trust me on that. It doesn't look like garbage. I mean, I'm in 16-bit mode, and if you would scroll, when you see all this, the out single out string word and so on, and the emule with the fs and so on, this is like about garbage. This looks like normal code, normal x86 16-bit code, especially with the presence of the interruption 13, which is a standard disk or no, that's the graphic mode, or I don't remember, or disk mode. Oh yeah, one of the standard interrupts. I have the book behind me. Okay, no, and that's graphical mode in interruption 10. Okay, let's forget about that. So basically, this issue is a master boot record, a bootable disk, and as you can see, you can try this with QEMU system and boot directly the PDF, and then you have the Berliner Spargel operating system. Mein Deutsch ist nicht so gut, aber es ist Spargelzeit. Because why not? And yeah, this is we have some jokes sometimes more or less hidden in the file, and Moonreviewer and so on. Okay, let's go back to our PDF, and it looks a bit normal from now on. This is a JPEG. This is a normal. Here you see that is flat decode and oh, sorry, maybe I'm too fast. This is a X object, which is often actually used as an image. The color space is device RGB, and the filter is flat decode, so which means it's compressed image, but it's not using something like PNG when it's a lossless image. Only JPEG was stored as is in the file. See what I mean? When you have filter DCT decode, the image is stored, the JPEG is stored as is, including all the tricks that you could put in a JPEG. But when it's a lossless image, then it's using it doesn't care any kind of PNG optimization. It's just zlib compression, so flat decode over deflate over raw pixel data. Okay, no questions. And now, well, okay, let's go back down, and we have a zip, and the zip, let's see if it's one. Oh, here we have object 9999 for the most of the bootable, and let's see if we have 999, only 39 this time. And yes, and again, same old trick. This is the zip is inside an extra object, and as you can see here, this is a standard xref, old school xref, and the zip is in the dummy object that is after the trailer and before the static ref. It's another hack possibility. You don't need this nowadays. I mean, there are more elegant ways to do it, but it still works, so why not? Now let's look for issue 3. And issue 3 starts with the with the JPEG. You could immediately tell with the JFIF. And very soon you see, you like, oh, JFIF, is it a JPEG? Yes, it has FFD8. But what should strike you immediately is that there is no, again, FFD8 is a single 2 bytes segment marker. I will show it again. FFD8, and then there should be FF and something. And here the JFIF is at, it's always, I mean, in this case, the JFIF is always at offset 6. And here we see the JFIF as offset 6, but we don't see an FF at all. And why was that the case? I think that's because if you remember, if Adobe was blacklisting PDF that would start with a known signature, and I think that Adobe made the mistake to detect strictly FFE0 and not another kind of signature, and or maybe they were using JFIF or something. I don't remember, but basically that was a detection bypass to just put that, and most likely the file was still working for whatever reason. I mean, in any case, the JPEG parsing is usually done via exactly the same parser, libjpeg turbo, and this is like super resilient. Like, you can put some garbage data and it will just jump to the next segment marker and still try to parse the data. So when I remember when I was trying to do hash collisions initially with JPEG for the malicious SHA-1 thing long ago with Jean-Philippe Masson and Maria Eichelzeder, then basically inserting garbage in the middle of JPEG could still work. It was not elegant, but that was the initial leads that I explored. So basically here there should be FFE0, and here it was removed to bypass likely the signature, the scanning of Adobe Reader. And just after the FFE0 here, unlike our standard JPEG here, we have an FFFE, which, as I mentioned earlier, is a comment. So FFFE is the comment marker, and then we have the length it's only on 2 bytes. So plus 22, and then we jump to the next segment. So but here that enables us, so if we highlight the content of the comments, this is exactly the PDF, how can I say, signature, and then a declaration of a dummy object, once again, that we called 999. We gave a number 999 because it works, And then we saw that after, this is just in a small comment, and then there's after FFDB, which is the defined quantization table standard JPEG segments. And here I won't go inside in the internals of JPEG. So basically the JPEG resumes, and at the same time the PDF was just declared, and a dummy object was declared to just skip any data that comes afterwards until an end stream string, a keyword. So a very easy trick. And now the JPEG is likely finished. And if we see just before, we have an FFD9 just before the end stream marker is here. And if we just go before, we have FFD9, which is the end of image marker of a JPEG. So basically, our JPEG is finished, and now our PDF object, dummy PDF object containing the rest of the JPEG, is finished. So now the JPEG is finished to be parsed, and the PDF parsing the PDF structure resume to a normal PDF, except that we have 9991 object and a lot of empty stuff. Oh, is it empty really, or is it I don't let's see. I don't want to check. I don't want to cheat. I'm just trying to remember. This would look like raw pixel data. I'm not so sure. Why is it not compressed? I wonder. Maybe we could have compressed that. Okay, that's not. What is that? What did we do? I don't, I don't want, I can read what it is, but I'm just trying to remember what we did. Okay, maybe arbitrary data of anything. I don't remember. Let's see. Did I close the tab? Okay. PoC GTFO. This is issue 3. Issue 3. Oh, yes, of course. I wouldn't guess. This is encrypted data with AES. So yes, I won't see that very, very easily. And AFSK, okay, yeah. So okay, that's something I not covered here, but basically this is a bit of a crypto polyglot. And to reveal this content, you need to apply AES. So it's no surprise that I cannot guess just by looking at the hexadecimal. I didn't rehearse perfectly all the files, so just to have some fun exploring the file. Now, is it still the same? Let's look up to PK. Oh yeah, maybe we should go back up down, maybe. Okay, another 9992 object, and we have the zip again stored in a dummy object. And here, this is surprising. There's no endstream object before. Maybe we were a bit careless. I don't remember. I mean, maybe it probably still worked anyway. But yeah, I mean, all this form would be very easy to. Oh no. Okay. So. Oh, okay. So that's the rest of the AES encryption of the second file. So the wow, I see. So the PDF is actually finished a lot earlier in the file, technically. Then there is encrypted, pre-decrypted appended data to the PDF that, after applying AES, will turn into a valid file. And then after that, so that after this garbage, this pre-decrypted content, then there is the zip file to that it was appended. And here, for whatever reason, we still put it in the stream object, maybe to please parsers, I don't remember, even though we are way beyond the end of file marker. Okay, now it makes sense. So, wow, you must be crazy to mix such files. I wonder who's responsible for that. Okay, now PDF 1.5, and let's see. The length is pretty big. The length is really big, and it looks fully garbage. I mean, not fully garbage, fully obfuscated. And let's see where it ends. And it suddenly ends with absolutely nothing at the end, again at the bottom. So I guess this is what we call TrueCryption. This is actually a TrueCrypt volume that was manipulated so that the salt of the archive, so that the salt of the file, of the volume, of the encrypted volume, is a valid, can be plain text. So long story short, to decrypt a TrueCrypt volume and maybe a VeraCrypt volume, if it's exactly the same format, I believe it is, but I might be wrong. A TrueCrypt volume starts with some salt, and then the header was encrypted with the key and the salt. So you have to provide the key. The salt is there to provide rainbow tables and preparation to the attack. And then the header is decrypted with the salt, and the header has a marker to make sure the header is once decrypted. So maybe the header starts here, I don't remember exactly. And then once the header is properly decrypted by the salt, the header only knows that it's properly decrypted if suddenly there will be a true TRUA marker somewhere. And then with the header being decrypted, then the whole archive, the whole volume can be mounted or whatever. So basically, you just need to decrypt the header, change the salt, re-encrypt the header with the arbitrary salt, and then you can put some plain text file in the plain text content in the salt of the TrueCrypt header. So, and yeah, we did this trick, and just a couple of days later, if I recall correctly, the TrueCrypt software was stopped, was terminated, like it was officially finished, which was yeah, I don't know, a weird coincidence, let's say that way. And if we go to endstream, another giveaway would be that the stream is rounded. Okay, maybe not. I was expecting that the length is rounded to a certain length. Here, yes, it is pretty roundy. Oh, well, maybe I'm wrong. Maybe my memory was wrong. I think it was a giveaway that TrueCrypt volume had always a rounded size. So it was nice to be able to provide it. This is a valid PDF document. There is a TrueCrypt document in it. It starts like a valid PDF. And this is a valid document altogether. So like really very different from standard TrueCrypt volume. Okay, then what's here? There is the PK56, and there is a length. There is a 3. I'm trying to remember why there is a length of 3, or it is 00. Or maybe I'm not sure. Maybe that was a mistake of ours. I don't remember why. In this case, our end of central directory, the bottom of the zip has the A at the end, maybe for customary reasons. I don't remember. So let's see. TrueCrypt, zip, and PDF. And did we start with the 999 object again? No, this time we didn't. So let's see for pkzip, the local file header marker. Okay. Oh, this time. Oh, okay. Yeah, we did it differently this time. I'm not sure you can see. We actually use proper embedding. The file is officially attached to a PDF. So let's see if it opens. So that's file 4. And can I see attachments? What is attachments? It should be able to see. No, there's no way to see attachments anymore. All tools. We used to. I think we tried that. The file is officially attached to the file, but I'm not sure nowadays. You cannot see the attachments. Okay, maybe that's not something that works anymore. But basically, this time we wanted to attach the file officially as an attachment in the PDF, and we did some scripting for that with PDF LaTeX, if I recall correctly. You have to declare some structure of the PDF output yourself to make, if I recall correctly. Okay. Now let's look for issue 5. Issue 5. Okay, so that's ZWS, and ZWS is so it's a shockwave file. So basically, shockwave file is the old name, Macromedia Shockwave, if I recall correctly, which was eventually called Macromedia Flash. Oh, okay. Well, the signature Macromedia Flash, and then Adobe Flash, and initially the SWF signature meant Shockwave, and then because Adobe took over that name with calling it Flash, they then call it small web file. And the Z one, the Z signature, is when it's compressed with zlib. So basically, this is why most of the content you see here is encrypted, because the whole thing is compressed with zlib, the whole data content. And let's see, can we jump? Okay, that was not the offset, or maybe with the FD. Neither. Okay, so there's a PDF, and if we see, we were a bit violent this time. We chose violence because there is a person PDF signature, and that's all. And then there is nothing like that looks like a PDF. And maybe, as you can see in the wild, the zip file still open. I don't think it will open in Adobe Reader anymore because there is the ZWS signature. But if we remove it, does it work? Yes, it works. Issue 5. So you see, even and yet our header is like super weird, right? Now we see there is a person PDF dash and nothing else. It's not starting with the usual PDF signature. And yeah, now there is eventually, after many bytes, there is a dummy object. That's okay. I'm spoiling secrets. Hey, you find a secret text file page in the PDF. We are cheeky. Okay, now what's up? What's this? A lot of space. This second object is huge and start with a lot of zeros. And what does that sound like when there's a lot of zeros at the start of the file? Then we have to scroll to 8,000. And yes, it's an ISO image. And we made this ISO bootable or something. So this was most likely a Flash and ISO image. and it used to contain, if I recall correctly, a bootable Tetris called Tetranglis. And yes, ISO record, and then we didn't modify the ISO in a very funky way. I mean, except that the start of the ISO, the first sectors of the ISO are a bit unusual. And yes, at the end we have the same. At the end we have the same zip, most likely appended after. Or if it's an ISO, maybe it's rounded. Yeah, well, you get the idea by now. Are there any questions? No questions. Okay, no, let's not spoil. 5 was an ISO and Flash. This is a tar. I'm not saying all the time, but very often I do have a poster. I have a poster for tar. So tar, lots of space. So here it's a tar, except that we decided to call the file name. Is it a tar? Is it a valid tar? Yes. I think the whole here, all this, if I recall correctly, let's see. No, this is not the tar. Tar, the whole file name is the first lines of the file, and we decided just to corrupt the whole file name, except that we inserted a 0 after the PDF signature, so that the file name that seems to be archived by the tar, stored in the tar, is just %pdf-1.5. So then tars are rounded at 512 bytes, 200 in hex. So this is the content, and yeah, and this is another file. So the first file is empty, and then there is a file called 1.png, and here's the content of 1.png. You get the idea. So basic tar, I mean, just a standard tar. Star stands for tape archive, and everything is aligned to 512. And yeah, it always have this weird header. And the magic is actually here. Even with the space, the magic, and there are various versions of star. Okay, you get the idea. What else? This time we decided to actually have the zip in a standard object before the static ref. Okay. No, not before the static. Yeah, before the static ref. And let's see. And it's okay, but still after the trailer. Okay, we didn't change that yet. I consider that a bit outdated technique now. So issue 6 was a tar. Oh, I lost my PoC or GTFO tab. PoC or GTFO. So issue 6 was a tar zip PDF. Now issue 7. Issue 7. Okay, so it starts with BPG, and BPG was a super compact, is a super compact image format made by Jérôme Bellard, the author of LZXZ, FFmpeg, QEMU. I mean, this guy is a god. And yeah, again, so sorry, you have here BPG, and then look at the hex FB, like Fabrice Bellard, not Jérôme Bellard. Apologies. And actually, and BPG was very new at the time, and so basically it wasn't blacklisted by Adobe yet. So I'm curious if the file that refused to open in Adobe. Oh, it doesn't. So Adobe never thought it would make sense to blacklist the BPG signature. And a funny thing is that I started manipulating, abusing the BPG very early in its making. It was still the early specs, and there were mistakes in the early specs, and because I added if I remember correctly, yeah, the BPG doesn't tolerate appended data. So basically, it's here BPG, then the whole PDF and zip, most likely. So for a lot of the file, and then the BPG content actually starts. So because BPG can only put arbitrary content in something, I think that was called extensions, and not later in the file, not in the middle of a file. So BPG was pretty restrictive. And the funny thing is that BPG was still very, very new. Again, the specs were still being corrected and evolving. And then I contacted Fabrice because there was this crash somewhere. And then I had to explain, yeah, I just wanted to use your BPG. But so the file is a valid BPG. You can view it. Let's see if it works. Do I have BPG view here? That's file 7. No, I don't. But it's actually HTML we see, right? And I think the reason why it's HTML is that there is HTML, the BPG decoding in the HTML code. So if we rename this to HTML, hopefully it will display the BPG image. If we're lucky. Are we lucky? We're not lucky. Maybe because things change over the past whatever decade. It doesn't work anymore, sadly. But yeah, that was in the BPG in the HTML code is actually the BPG code that used to crash because we came up with this very weird file. Hey, I mean, after all, this BPG file is 33 megabytes, and it was supposed to be a super compact format. I mean, it is a super compact format. So yeah, I had this awkward conversation with Fabrice Bellard. Let's see if I still have it actually. Yeah. No, BPG. When was that? What year was it? BPG. No, I didn't have an email for Fabrice. My memory is failing me. Oh, my BPG are troopers. Ah, yeah. Okay, yeah, 10 March 2015. Thanks for thanks for promoting BPG. Oh, I forgot because apparently I already also created a challenge that was based on BPG for the conference troopers. I forgot about that. Okay. So my memory fails me. Oh, okay. So because now you need to launch Chrome with the allow file access from files to something like this. I'm not sure. Anyway, that was just potential fix to get the HTML working on the Chrome nowadays. So now we went through the BPG file, BPG HTML as you saw, and zip and PDF. That's one is pretty explicit. Hey, I'm a shell script. Please make me executable. No shebang. I work equally, and so on and so on. And so it looks like a shell script, pretty obvious. And then there is exit, which acts as a terminator, and then there is just a PDF starting normally. So yeah, looks like a normal PDF after a shell script. And there's a zip at the end. Was issue 8 a shell script? Okay. This one is pretty self-explanatory. Is there any Easter egg? Oh yeah, I'll let you look. Issue 9. Okay. Very, very easy to identify. WavPack. And WavPack works with those frames. And there's the length of the frame is just at the beginning, so 55 in this case on 4 bytes. So you see it's until 55 here, and then there is another WavPack marker. And so basically, that's how you see what I mean here. It starts to declare in the WavPack, the first frame of WavPack, it starts to declare the PDF, an object, and with a huge length, and that's probably the rest of the WavPack file. So pretty straightforward from a PDF perspective here. And maybe, I mean, again, there are probably needs of chunking stuff with the WavPack file. So 7EFF and so on. So probably can't I? Oh, and now this is the next marker and so on. So basically, yes, the whole file is in a WavPack. The rest of the PDF, sorry, the rest of the WavPack file is in a PDF object, in a huge PDF object, and then the PDF finishes with the zip inside. And just to close the final part of the WavPack, then there is the AP. So AP means is a AP format, audio. It's a lossless format. I forgot what it stands for. AP. It was monkey audio, right? Because it's ape. Monkey audio, which is a lossless file. Monkey audio, and it's using ape. Okay. Yes, indeed. Now, so issue 9 was WavPack, zip, and PDF. And issue 10, okay, that's what was it? LSMV. It was a movie file for emulator for tools-assisted speed runs, and basically it was a recording to exploit a Pokemon game, if I recall correctly. And you see the structure here, PDF and so on. So at this stage, it becomes pretty boring. I'm joking. Yeah, PDF stuff, and here the PDF at the end, the zip at the end. So is issue 10, zip and PDF. Okay. Issue 11. Okay, require JSON socket, require URI, and these are, how is it called? Begin and end. So this is Ruby stuff, and you can see that it has those begin and most likely end markers. I forgot how it's called. Well, you could call it multi-line marker, or it's multi-line declaration. And basically here begin, and then basically, yeah. Oh, sorry, just here. So begin, and then it goes to here, the end. So begin, again, same trick, declare a PDF signature, a PDF object, a length, and a stream, and finish the PDF, the Ruby comment, the Ruby multi-line comment, or I'm not sure how it's called specifically in this case, and resume with Ruby code. And very likely at the end, there will be a marker to stop the execution of Ruby, exactly the underscore end to, because Ruby had this ability that Python doesn't, as far as I know, to stop the parsing, and then you can put whatever you want. And here is HTML, because why not? And we are still in our PDF object of a length of 109.44. And as you can see, we finish our objects and the HTML of it. And now we resume a normal PDF. If there are any Easter egg, it's totally an accident. It's totally coincidence. And well, yeah, because it's HTML page, we finish with a comment so that this is not to be included in the rendering of the HTML image. Any comments at this stage? No questions. Okay. Okay, PK dot PK. So maybe we put this fake signature. This is not PK. Dot is not a valid zip signature as far as I remember. So I assume it's because we just wanted to fake the actual PK signature so that the file would open under Adobe. And now we have a local file header with PK34. Sorry. PK34, and then we have the name. And then it's likely we have the trick of, this looks like, so here we don't see the 08 of deflate. And basically that means data is stored, and basically the file is in clear. So basically, it's a HTML file that is stored inside the zip. So this file is the outer of this file is a PDF, is a zip, sorry, that is containing a PDF in a stored way. So basically, a PDF. It's not a zip inside a PDF dummy object. It's a stored PDF inside the zip. And what else do we have? PK. Do we have anything special file-wise? The rest of the zip, okay, but we end up with another zip. Did we concatenate two zips? I'm just confused here because we start like a zip. Oh, this is because there's another. This is a PoC or GTFO printf, but this is the first PDF in the file, first PDF signature in the file. So that will be considered an actual. That will be considered an actual PDF. Oh, okay. So we did this trick again. Okay, I'm not sure why. And then after the end of the PDF, we put another. Okay, so it's a zip of. Okay, why not? We kept trying different stuff. Oh, my mistake. It's also an APK. Oh, okay, of course. Okay. So then, oh, okay. That's a bit more. That's not your standard. Okay, yeah, I should have looked here. Okay. Oh, yeah. Okay, yeah, I looked too quickly. Okay, this is really, yeah, okay. Yeah, okay, so APK and zip, because why not? Issue 13. Okay, that's PostScript. And yes, and you can actually, you see there's a fake. So that's a function declaration, if I recall correctly. And then, sorry, oh, it will create this bug again. Come on. This is annoying bug with you. Oh shit, where's the file? I forgot. This file, okay. So basically you declare a function that will never be called, and whatever is in this function will be ignored. So you can put garbage inside the body of the function as long as, maybe if I recall correctly, the parentheses are balanced, which is not what you expect. So basically you abuse a function that will never be called to contain whatever you want, as long as it's, again, the parentheses are correctly balanced. And then, so basically here again, there is a PDF signature, a declaration of an object with the actual length of the object. Then the rest of the PostScript is hidden inside the PDF object. What's happening here? I don't remember. Any questions at this stage? Okay, no questions at this stage. Yeah, okay, it's PostScript. And yeah, oh yeah, wasn't it that we put the whole first page? Oh no, we put an actual, we continue the article, okay, inside the PostScript part of the file. Wow. We were having fun. Okay, that's a Nintendo Entertainment System. So not officially the NES ROM, but the iNES header. So an unofficial header from an emulator. And if I recall correctly, it's like here you set a bit, and then you have 512 extra bytes for trainer. So basically to apply some code on top of the actual ROM, and you can abuse that, yeah, in some ways. What else? Wait a minute. If it's NES ROM, doesn't that mean that we wasn't it when we did? Yes, this is also a Hashquine. Okay, I'm not gonna go too much in details here for the whole file, but here, I mean, at least from PDF perspective, it's pretty easy. But this, yeah, this ROM itself was quite special because it was a Hashquine, but then the rest of the file is a normal PDF. I mean, from outside perspective, inside the PDF, a lot of weird things is happening. I'm not going to go into details for this one today. We didn't. I didn't cover hash collisions in my talk already. You can see you regularly have this weird structure, which kind of indicates with high entropy aligned to blocks of 64, which is a big indicator of hash collisions. And here, just a small, and here FFFE. Oh yes, this is a JPEG comment. So we are in the middle of a JPEG abusing hash collisions with comments of different length. Yeah, but this is still the JPEG inside the PDF, right? So it's not. I mean, the JPEG is special, but from an outside perspective, it's still the same thing. Okay, so Hashquine at NES and PDF level. So basically, I haven't mentioned that already in my streams, but I did mention that in my talks, that the hash of the file at the bottom, it's a bit ugly, but the hash of the file is the actual, this displayed here is the actual hash of the file itself. The hash that is displayed by the file, the MD5, is actually the MD5 of the file itself. And if you would run it into a Nintendo emulator, you would actually get, do I have a Nintendo emulator here? What's the name of my Nintendo emulator? I forget. What name did it have? Pocket something? No. Okay, where do I have Nintendo ROMs? I don't see where I have. Sorry, I want to run this file. BizHawk? Do I really have only BizHawk? Oh, FCUX. Okay, of course. Let's see if I'm lucky. Yes, so that's the ROM. Run the same file running on a Nintendo emulator, and you see that it's displaying seafood. That was beautiful work by Evan Terran and Evan. Sorry for the names. Oh God, sorry for Evan. I see you. Too many Evan. Evan Terran and Evan. Oh, I'm so sorry to forget your name just right now. So much. Sorry, so much in my head. Oh, I see your black and white avatar. Oh, Trail of Beats, Evan. Ah, come on, I'm gonna hit my head later because I haven't been good. God damn it. So who's the Evan Trail of Beats polyglot master with an awesome resume that is also a polyglot? Oh, come on. I'm gonna hit myself. Evan Sultanix, sorry, Evan. I remember Evan Terran and not your name, Evan Sultanix, because you're just Evan to me. Oh yeah, you get the idea, but god damn it. Anyway, would be interesting to see the script of this, to see the script of what? Hi, Constantine. It would be interesting to see the script of which one? The Hashquine? Because it's a bit complex, but definitely I will cover PDF LaTeX hack in a further presentation, in a further stream. So yes, I will show how it's possible to make this, because again, these files were generated via PDF LaTeX. There was some post-processing, there was some pre-processing, but at least there was a lot that was being automated by PDF LaTeX. It was not entirely post PDF manipulation. I mean, just by hand or at byte level, we are still relying. ILDA is infrared. No, not infrared. Laser, International Laser Display Association or something. And basically, this is a format that we discovered thanks to Marcan, if I recall correctly, Hector Martin, and he provided. This is nothing too special. I think every frames has the ILDA signature, which is a bit unusual, but then you see that the file structure is a bit I mean, the tricks are the same at this stage. Now there is the ILDA data, and eventually the PDF resumes, and that's all. And this is what it looks like to have this was the avatar of ILDA of the displayed with a real laser. So not too complex and as a format, but the same tricks this time. And yeah, but just a very lesser known format, except if you have some laser stuff to do. So basically not blacklisted by Adobe. Okay, okay, no, I shouldn't spoil, sorry, wrong window. Offset 16, padding bytes to support a nifty trick, Python start. Okay, I'm not sure what is it. Stream object Python start. Okay, but it's not a Python start, so it's a shell, most likely. And then I'm not sure why there is a Python. Do we need alignments? I'm not sure why. Is there a hash collisions? A hash collision? Maybe. No, it doesn't look like a standard format. Or maybe there is encryption. Okay, what's that? And the end of an object, and then there is the end of the Python start. Okay, there's a blob. Still not sure what this was about. Okay, PDF padding. Okay, I'm still trying to get it myself. And Python. Okay, and then the standard. Maybe. Okay, this is weird, but I don't see anything else. And then, okay, at the end, standard zip. Let's look for PK34. Okay, same, old school Xref. So what was it? Polyglot, Bash, Python, Web IDE. Okay, so just nothing too special, except that not in the way that I expected. But yes, you cannot do a Python polyglot because Python doesn't like weird encoding and doesn't like appended data. So it's really annoying. So basically, you have to use some trick to. Now, issue 17. Okay. I wonder who that guy is. And yeah, welcome to. Oh, nice. So that was before CCC something. So PDF, zip, and Apollo guidance computer. And this was okay. So that's actually AGC, Apollo guidance computer. Indeed, that's AGC code that I wrote myself. And you could run into an AGC VM, for example, and that was to display with the digits and so on, hello world and 33, 43. Yeah, that's from my code. And if I recall correctly, I use a trick to terminate, because otherwise it would pass the rest of the file, right? So far it's text, but it would just parse everything and then the rest of the PDF and whatever. And instead, yes, I included trigger to trigger a recursive inclusion error. So the file will still work, but will stop parsing any further because I created an infinite recursion. And yes, that was thanks to Michael Steil and Hesse, don't remember his name, for the help. This is when we worked on the AGC, their talk at the CCC, and me, this polyglot. Oh yeah. That was a really brilliant talk. Congrats again. Yeah, and then that's probably the rest of the PDF in a standard way, and then with a zip at the end. Classic, as usual, like any PDF. Now I think there is something that is when you have SHA-1 is dead. This is a shattered, so it's a SHA-1 collision, and I crafted this header as a Googler with Mark Stevens, and this is basically a SHA-1 collision. And if you're not familiar with the SHA-1 collision, it's not a PDF collision, it's actually a PDF, a collision on a JPEG inside the PDF file. And basically, you see that it starts to indeed declare an image with type and so on. Then it starts with the FFD8, then with the small comments that will jump over the SHA-1 is dead signature for alignment reasons. And then this is the magic trick. Here it starts a comment, a JPEG comment segment, FFFE, just at the boundary of 40 in hex because of the size of 40 blocks in the way SHA-1 works. And then 01, and this byte will be modified by the SHA-1 collision, but while keeping the same SHA-1. And at the time, that was the first SHA-1 generated ever, and we made this header so that it work with generically. And now the SHA-1 magic is done. You would have different values of this here. There will be more different changing values in the file, but this one, how can I say? After the collision block, you can put whatever you want, including some ASCII art. And yes, then let's see. Hopefully it works again. I want to try the JPEG, the PDF, the HTML payload. Sorry. Oh, okay. That's the HTML payload. Okay, that's not the HTML payload that I was thinking of. Okay, and what did it look like? So really, okay, I don't. Is that? Okay, that's something else. That's on the initial shattered file. I don't know why I hide here. Okay, I wanted to show, but basically the trick was that the rejected stamp becomes an accepted stamp in green, and the files both have the same hash collisions. So as you can see, the collision is just on one file, and you can see, and maybe we added a coffee stain in the other version. I have to check. Where is it? Actually, maybe I could do it myself, So that's the shattered file. That's the other shattered file. And we can see that 7.3 is changing to 7F. You see my cursor. So you see I'm swapping from each file, and both files will have the same collision, the same SHA-1 value after the collision blocks, 7.3 to 7F. And now if I take my PoC or GTFO 18 file, and I say 7.3 to 7F, 7, so now we replace it with 7.3, and 1.7.3 will jump to a different place, and now we got a coffee stain and an accepted stamp in green. And I remember Travis Goodspeed measuring the size of his cup to accurately know the dimension of a realistic coffee stain, because why not? I'm having fun. Yeah, so that's basically that was so Mark Stevens and I designed the start of the header, the prefix of the SHA-1 collision, but initially that was not supposed to be. So that's what that's what the file both look like, just a change of color. But then we eventually try. I mean, I managed outside of the Google project to get it usable via PDF LaTeX. So basically, to make sure that you have the the actual SHA-1 collision reusable by a standard and yet generate a completely standard PDF LaTeX article around it. And maybe there should be the article about it, because of course, and if maybe because it's an image that is being replaced, there's no article about the SHA-1 collision. Oh yes, here is it. And here you see that the picture is being repeated again, just because you can reference the image several times in the file, And here I introduced the PDF LaTeX statement to make to generate something that is similar to the SHA-1 collision header, so that the SHA-1 will be still valid, and then you can abuse it. You can then reference the image, the modified image, the colliding image, directly in your code, as we did, So that was pretty funky, pretty interesting to do. Very impressive coffee stains. Thank you. Now we should have. Oh, sorry. I opened the file, but what is it? MD5 and PDF prefix Ange and Mark. Mark is being Mark Steven, the god of hash collision. And if I recall correctly, if I open it as HTML, hopefully it works. Oh, yes, I love that. And thanks, Rafael, for making this. So you drop the file. So this is the same file open as HTML. You drop it, and it identifies, oh, currently a PDF polyglot. And it was like, hey, but it contains how to get the other prefix that were computed, the HTML code, that is, so that you can resave the file, keep the MD5, and then have a very different format. So basically, save as PNG. You save as PNG. And now this is the same file. This is the same file as a PNG. And of course, the PNG is a diagram of the PNG, the collision structure. So this is just MD5, but these are 4 headers combined to work together. And here I maybe not go through it with the hex editor, but it was great fun, and because that was so nice. But it was actually not trivial, because these are chosen prefix collision. It was not trivial to switch from one payload to the other, because the prefix are just different. They are chosen prefix, not identical prefix. So basically, the JavaScript stores the JavaScript file is storing the content. Can I see it here? The JavaScript file is contained. Yeah, exactly. The prefixes here are stored identically and being restored by the JavaScript on demand. So you can say save as PE, save as MP4. All these files have the same value. And now, okay, whatever. Oh, okay. And the MP4, does it work? No, it doesn't work. Maybe it does. Maybe it doesn't work anymore. Yes. Oh, okay. I'm going to show it very briefly. The MP4 file was something that looks like a collision about to happen, because why not? And the PDF is, of course, the executable, sorry, the P is a PDF viewer. So you can view the file on itself by having, so you can view so much the file in itself, and the viewer and the file both have the same hash, because why not? You must be crazy. Maybe we are. Okay. Now what? We almost done, no? Issue 20. Oh, it's funny. Because I remember, well, who was it? Malware Unicorn. I remember you complaining, who's the idiot who put the ACAR file in the PDF object, and that's me, because why not? And actually, it's pretty weird that this file is not being detected as the ACAR file, but another one. What was it? ASU19? I had to rename it, I think. No? No, it's not this file. I'm confused. My memory is failing me. Okay. Okay. Well, anyway, you get the idea. Yeah, we sometimes put the ACAR file. So because, yeah, why not detecting it all together to avoid any true false negative, like, yeah, this is a malicious file, delete it from your system if you don't know what you're looking for. PDF 20. What's this? Oh, again, this bug. I'm going to close it. Okay, what is that? That's okay. Why are we using prev? Is what I called in the last time. This is incremental update. I'm not sure why we did that. Oh, maybe we did. It was at the time where I thought it was a good idea. So basically, we added extra data to the file by an incremental update so that you could very cleanly remove extra stuff from the file, because why not? After all, it works. I'm just trying to remember why in this case specifically. Yes, there is something. Okay, there was a key that was leaked and this stuff was signed, but why? Oh, and then we applied the signature as an incremental update. Yes, okay. So this file being signed with a special key, but I think that's all it has from a file perspective. Oh yes, PDF, zip, and sign. Okay, indeed. Now 21. Okay, what's that? What's that? What's that? What's that? What's this format? 0D, 0D, 0I. Okay, what is that? I'm just confused. Zip, no, zip and something at the end. I'm just oh, 0D. That's not PCAP or something. No. What's 21? Yeah, PCAPNG. Oh, sorry. Oh, PCAPNG, because I usually use more PCAP. Okay, that's a PCAP, and I don't think there is anything very special here except special packets and storing the whole file, and then some terminator after it. If I remember correctly, it's like the length has to be duplicated. Isn't it the case? Isn't it something like this, that the length has to be duplicated before and after the packet? But maybe my memory is failing me. Or is that in PCAP and not PCAPNG? I don't remember. But yeah, yeah, that's about it for that. And the rest, I don't remember if it has any very specific structure. And now the last one, that's a PDF. Oh, okay. There is a ACAR file here, and these are all. So this is the DCOM signature for medical image, but a DCOM would have. I made a DCOM poster in my website. DCOM, where are you? DCM, DCOM, where are you? There's no DCOM. Please, DCOM, appear. Yes. So DCOM starts with the preamble. So like it could be whatever you want. Then it starts at 80. Then it has this very strict, stiff-like structure. Like nothing should be wasted. And if there is appended data, the file is considered incorrect. But then you can just add a trailing comment, what I call wrappending. So you wrap the rest of the file into something extra. But DCOM is pretty strict, just right after the signature. And here you totally don't have that. And here you have some stuff that are totally unrelated. Must have those version and ACAR virus and whatever. This is a Polymock, so like a mock file with a lot of a file with a lot of mock signatures. And do we have? No, we don't. I'm just trying to remember. Okay, no, okay. So basically, it's a Polymock. So this whole first object is used to store a lot of signatures. So you would have a lot of false positives regarding detections, just because to show that, like just detecting the magic is sometimes not enough. Oh yeah, and let's store a few other ones just because, why not? And these images, these signatures are not aligned, but they will still trigger with something like binwalk. Just a lot of signatures, random signatures, and you see they're all aligned on 16 bytes for visibility, for readability. Okay, and I think that we are done. Polymock. Oh, it was ISO too. Oh, okay, I missed that. But and a mock and a lot of mock signatures, a shitload of them actually. I didn't see the tar file. utar. Where is it? Oh, this is this. So it's called a star file because the tar checksum is valid, but I don't see a tar signature. Maybe I'm mistaken. But I think this is a tar signature here. A checksum. It has the tar header has to have a valid checksum, and I think that's the reason. But yeah, that's still weird because I would assume there would be a utar signature. Okay, well, okay, you get the idea. Yeah. So that's the last of the PoC or GTFO. As you see, we had plenty of fun. Of course, there are a lot more Easter eggs in various ways in the files, as a binary level, in the PDF LaTeX, in the rendering of the PDF. And yeah, I probably forgot a lot about it. But yes, you see that polyglots can really go over. Some of these files are huge, like some are 80 page. I think that was limit. Wow, issue 15 is 100 page, and issue 15 was ILDA. So you see that it's really possible to combine stuff. And sometimes this, I mean, we were still testing for the compatibility of these files. So well, we put a lot of creativity. So Travis, Philip, Evan, and so on. Yeah, lots of creativity. That was great fun into making all those issues. And I hope you had a good time. That was a long talk, very long talk. Oh my God. But yeah, thanks for your attention, everyone. And yeah, see you next stream. Bye, everyone. Legendary for former hackers. Thank you. Yeah, it was fun. But yeah, now we created tools to automate all that. I mean, we automated that on a case per case basis for each of these issues. But since I created a tool that I will present I mean, that's already public, but I will make a stream about it in the future. Yeah, thanks, Yuansh, for the presentation. Thanks for your attention, Konstantin. And yeah, have a good evening time or whatever. And see you next stream. Bye, everyone.